All right. Good morning, everybody.
Good morning. We're happy to have you watching with us today. Debbie was teasing you a little bit. That view looked pretty nice, but it's so windy today. We're actually going to be doing an experiment inside, and we're going to be thinking about habitat preferences today. And the species that we're going to be working with is a crab.
Before we go any further, I just want to take a quick minute to shout out all our teachers and students who are watching. I know we have some people from Watertown watching. Lyman Memorial, good morning. If you are watching from home and you want to tell us what school you attend or work with, we'll give you a shout out on video. We're also going to start by looking at the crab, the species, the Asian shore crab that we're going to be studying. So let's brainstorm very quickly. What kinds of things an animal needs from its habitat. Okay, so go ahead, post those things in the comment, what school you're going to, and what animals need from their habitat while we take a closer look at this crab. All right, I'm coming in close.
All right. Ready for camera. So this is the Asian shore crab. If you've followed us before, we have found these critters right on the Rocky Intertidal here in Groton, Connecticut. You can find them along the coast in Connecticut.
He's frothing up for us.
This is a pretty nice specimen. It's a little bit larger, so we brought this one specifically to show you. You can see that sort of squarish carapace that it has, right? This sort of carapace or shell. The legs have stripes on them, so that's kind of another clue that helps us know that this is an Asian shore crab. Debbie, can you see the teeth on the carapace in that view, or is it tricky to see?
Yeah, actually I can. There are 3 little spikes on either side of their eye stalks. So I don't know if you can point that out for me.
I'll try to point, but 1, 2, 3.
So that's another distinguishing feature. And also, I know that this guy is a male without even looking at his underside, because he's got like that little bulb in between his claws there. Mm-hmm. So I know that this is a male crab, but the other way I could tell is to look at the underside of its body here, and that sort of, don't touch me. That sort of lighthouse shape there indicates that it's a male. On a female, be nice and wide and round, like sort of a dome. Oh, we got a couple people from Windermere in elementary. Sorry, not in elementary, in Ellington. I'm seeing some guesses about what animals need from their habitat. So I'm just going to share some that I saw. Safety.
Right.
Food and water. Food. Let's see, a couple other people. Shelter. Colors surrounding habitat that helps to camouflage, right? So we saw some colors there that might be good for camouflage. Mm-hmm. We got safety, shelter, food. Yeah, mostly those things, right? So animals need a way to avoid predation. So that might be somewhere, some safety that they can hide, places to hide, or things to camouflage with. They need to be able to find food. Mm-hmm. So we got to be thinking about what these animals need. So what kind of food do our Asian shore crabs eat, Callie?
Well, take a look at those claws. That might give you a clue, right? So those claws are going to help them to find food in the intertidal. So surprisingly, these crabs are actually omnivores. So omnivores meaning they would eat plant material, but they also would prey on animals. So those claws might help them to crunch through another kind of crustacean, or maybe even a mollusk that might be on the shore. But pretty much they're opportunistic. Anything they could fit in their mouth or grab with those claws, they would.
Nice. Oh, yeah. So Jennifer guessed that they might eat little fish. Yeah, if they get the chance, I'm sure they would.
Yeah.
So usually we find these in the Rocky Intertidal, but they could find them in different spots as well. Mm-hmm. So looking at their body, we can make some guesses about their camouflage and how they use their coloration to help them. And so then we could think about food. They're getting all the water that they need because they usually live in water, but you could see that our little friend was bubbling at the mouth there. He's got some water trapped inside there, and he's kind of bubbling it out and using it slowly. And now he won't do it now that I have it on camera.
I just got it wet. You can see it starting again.
So even when we hold them out of the water for a little while, they're just fine. They can sort of ration out that water and use it slowly and get the oxygen out of there that they need. And that's a good strategy for them, right? Because sometimes we know that they can be exposed to the air.
That's right.
All right, so we've got some ideas about what crabs need from their habitat. Now we're going to design an experiment to see what kind of habitat they prefer, where we would most likely expect to find them. So we've got a little model ecosystem. Right now, all it's got is the water. We're meeting that need already. So let's take some hypotheses. We're going to set up an experimental design here that includes 4 different corners of this container. So we're going to set up a couple different habitats where we know we have found shore crabs before. So the first habitat is going to contain algae. So this is just some algae we found in the intertidal zone. It's a mixture of a lot of different kinds of algae. There's some, looks like some washed up eelgrass, there's some rockweed, a couple of red algae that's kind of wrapped around in there, all kinds of different algae. So we weren't specifically testing what type of algae it likes, just generalized floating algae space. We're also going to put in
some sand, right? So if you've been to the intertidal before or into Long Island Sound, you know that there are some sandy beaches. So we're going to use some sand in this corner to mimic that habitat. So just pouring that in. Trying to do my best to keep each habitat contained so they're not crossing over. All right.
So one corner is going to be just the algae. One corner is just the sand.
And then,
of course, the rocky intertidal is represented by rocks.
So I'll get a variety of rocks here.
Different sizes.
Yep.
Makes sense.
Fill up that corner. All right.
All right. So as a scientist, we want to make sure that we are not influencing the decisions of these animals and that they're making their choices completely based on their preference. So we're going to leave one corner totally empty. We call that our control group. So we're just going to leave that empty and see if maybe the crabs just prefer corners. Yep. And it isn't because of the seaweed or the sand or the rocks. So at this point, I'd like you guys to make some predictions about where we will find the most crabs. What we're going to do, we have a little cup full of crabs right here. There are 10 in here. We're going to put them in the center of this container, and we're going to start a timer, and we're going to watch to see what the crabs choose. And we're not going to just see what they initially choose. They're going to have an opportunity to change their mind if they're not super excited about the choice they made. So we're going to put them in the middle and watch their behaviors. But at the end of the experiment, where do you predict we will find the most crabs? So post that in the comments. Since we're scientists, we like to defend our ideas with evidence or background knowledge. So think about what our animals look like, what we know they need from their environment, protection, food,
water.
And water. So they might be able to find all of these things here. Okay. So let's see. Little crabs in the cup here. We got 10. Iris thinks they're going to hide in the rocks.
Okay.
Kyle and Christopher think that they're going to be in the algae. Oh, and Jennifer too. So we have a couple algae predictions.
Okay. So nobody picked control so far.
Nope.
Okay.
Let's see. Oh, Molly is defending her idea because she said because it would be easiest to hide there.
Okay.
So,
I like that explanation.
Yeah, excellent. So it'd be really easy to kind of hide in there, slither inside there, and not be seen by a predator. Maybe also because of their coloration. It's not that far off, right?
Yeah, good camouflage. So that
okay, we got a second guess for sand. I wonder why we would think sand. Maybe there's a behavior that crabs do that would allow them to hide in sand. Let's see. I got another guess for algae, but then they changed their mind to sand. Yeah, so right now, they're probably going to make a choice. Jennifer's right. They're going to make a choice to want to go hide because they can't tell the difference between a scientist and a predator. So we have another background knowledge here. When Molly worked on baby lobsters, they preferred the rocks, so she's changing her idea. So crabs and lobsters have a lot in common.
Right.
And they might be able to fit in between the rocks.
So that's a good connection.
Maybe different sized crabs might have different behaviors too. So if we have like one that's size of, a spider, really tiny, and then one that's, almost as big as like, a quarter, they may make different choices. So that's something else we could test. Okay, so Iris is using some background knowledge because they live in the rocky intertidal. We expect to find them in the rocks.
Okay.
All right, let's get started. So I've got my timer right here. So we'll look back at this periodically. But as Callie puts the crabs in there, I will start the timer.
Okay, here
And
we go. Good.
Yep, go. Okay, there they go. Skitter, skitter, skitter. Okay, it looks like they're already making some choices. And after the first minute, we're going to try to count how many crabs are in each spot. So I'm going to rely on you, Callie, because it's kind of hard for me to film and count at the same time.
1, 2, 3, and we can have
So I don't know if you can
viewers at home too.
Yeah, maybe you can help me out. Where did they go? There is one guy who's choosing the control group, but I don't see any in the sand yet.
Nope.
They might change their mind too, especially this corner guy. I don't know.
Oh, moving the rocks. So I see 3 in the rocks. Hopefully you guys are counting the same as I. We've got 1 over here hanging out in that control corner. I don't see any that have gone to the sand.
I agree. Oh, look at our control group guy. No, he's getting edged out.
By a bigger crab. That's
Now,
interesting.
He's leaving. See, I'm telling you, they're making choices here. So we are coming up on our first minute. So maybe, Callie, you'd like to go to the board and record. We have, it looks like, I think 4 in the rocks.
Yep.
1 in the sand. So that would make 5 in the algae. No, I'm sorry, 4 in the algae and 1 in the control group.
4 in the rocks.
1 in the sand.
1 in the sand.
4 in the seaweed.
And 1 in control.
And 1 in control.
And 0 in the center.
0 in the center.
Okay.
Correct. Okay. So the second minute has begun. We're going to continue to watch them. Now let's think about what kinds of things might influence their change. If they're not just staying in one spot, what might cause them to move to a different corner? Because this guy's mobile. He's
scurrying.
a very choosy crab.
Well, one of the things I noticed was that size difference, that interaction that we just saw. It looks like the bigger one kind of chased out the smaller one.
So maybe there is a preference for that, or maybe that crab realizes that that is the best option for his size of crab.
So I still see one kind of thinking about the sand.
We missed our 2-minute mark.
Oh boy.
So I think we still have the 1 in the sand.
1 in the sand.
And our control group moved to the algae. So we have 1 in the sand, 3 in the rocks. So that makes...
should be 4 in the rocks, I think, 1 in the sand, 5 in the seaweed, right? 10 altogether?
Yes, that works. Yep.
Okay.
I was talking and not counting. Yeah, so larger crabs might be competing for that space. So there is... Oh, good morning, Mr. Dole. Oh, did I miscount, Chris? Let's see. No, that's right. Okay, that's what we recorded. Yeah, they might be exploring. They might actually be doing some foraging right now, looking for food in between rocks or in the sand or in the algae. Since they're omnivores, there might be some good eating in there. Who knows? Now, what would happen if I got really close to the crabs right now to count them carefully?
What do you think at home?
Right,
If Debbie or I got too close, or what if we even put our hand
any change
into
in that
the
last
water?
minute?
What would you expect to happen if we put our hand in or got our face really close? Type that in the comments. I'm curious. So 3 minutes, Debbie, no change, right?
No change, yep. Although now our sand boy is leaving, but that's okay.
Okay.
We'll get him in the next minute. Yeah, so if we were to disturb the water, we would be influencing their behavior. Yeah, Jennifer said that they might run away. Right, so they might change their behavior based on what we're doing. And so we don't want to do that. We're trying to count as they move. Oh, the sand, actually I think they made a switcheroo. I don't think even that's the same crab.
Yeah, so that's a good point. If we started putting our hands in here, this would be more of an experiment about predator-prey perhaps than habitat preference. So it would be a different kind of experiment.
So there are all sorts of things that might influence their decision right now. Competition, looking for food, or maybe hiding from predators. So we're trying to eliminate the hiding from predators part of the equation.
A bigger one kind of moving a smaller one maybe? I don't know.
Okay, we just hit 4 minutes. We actually missed it again. But now we got 3 in the sand. And so that means there's only, I think...
2 in the seaweed?
2 in the seaweed.
And
the 3 in the rocks, 4 in the rocks have stayed put and 0 in the control.
Oh, so I missed one somewhere then.
I did? Ooh. I got 1, 2, 3, 4. Oh, we got one emerging from the rocks as we speak.
Woo.
Okay. So any experimental design that we have here is not 100% perfect, but there are things that we could do to experiment further. So if we wanted to see whether crabs prefer all the same size crabs, we could find crabs of all the same size and then see if that changes their preference. Yep. We could see if it changes whether they are male or female. The choices might be different. So there are all different kinds of versions of this test that we could do. Oh, good morning, Waterford High School. Oh, that's a good point. Hazel says they might actually hide under our hand if we created enough shadow and held still. Yeah. We could actually be part of their habitat.
All right, so it looks like another one. Oh, I was thinking about the rocks and...
Okay, we're at 5 minutes now, so let's do a count. Okay. Let's see, I got one in the control group. He looks a little confused, I'll be honest. Looks like we have 3 in the rocks, 2 in the sand. And so that means 3, 2 is 5, 6, so there must be 4 in the seaweed. Yeah, we are doing crab math, Iris, you got that right. Because I couldn't keep track of them all. I have to kind of process of elimination here. So we've done this for 5 minutes. We've actually set up a test earlier. We started half an hour ago. We put the crabs into another habitat that we tried to make as close to this one as possible. And we want to see if those crabs are making the same choices as our crabs here. Okay. All right, so I'm going to come over to our second habitat here. And I'm actually going to disturb them to count because there are 10 in here also. Okay. But I can't see them all right now. I can see one in the control group.
I'm going to grab that one and put him in this container so we know, whoop, that's
put him right in the cup.
It looks just at first glance, I don't see any in the sand, so I think I'll try to move the seaweed out of the way and let's see what we can find in that corner. I can see one just kind of chilling right there. I'm going to, get back here. Yep, so that's 1.
2 in the seaweed.
3, 4. Ooh, that's a good one to show, Debbie.
Oh, wow. We have a female here who's going to be a mother. Congratulations. She's got eggs there. You can see that dome shape on the underside of her body and this entire mass of sort of orangey brown stuff right there. Those are her eggs. So she'll carry them underneath her body, protect them. They start mating and reproducing in May, and they'll continue mating and reproducing all the way through September, October. They can have 3 or 4 clutches of eggs every season.
That's pretty impressive. So that's a total of 6 for that corner, and that was the algae corner. Let's see who's hiding out in the rocks.
Anybody home?
Oh yeah, all the way in a really secure spot. Oop. 1, 2.
You come back here, you. You still count as rocks.
3. Okay, so
all right.
3 in the rocks.
3 in the rocks, 1 in the control group. We had
6
in there and 0 in the sand. How does that compare to our numbers before? So let's consider all of these crabs. We had 20 total crabs. Oh, good morning, Joseph from Franklin.
Okay, 6 in the rocks, 1 in the control.
0 in the sand and...
0.
Oh, no, there's... you're right.
3.
Yep, 3. Yep.
Whew.
Okay.
All right, so the center, I can see right off the bat. Look at no crabs ever chose
Goose
that
eggs.
spot. So
nobody really liked being in the center. They all went to the corner. So maybe crabs like corners. That's a possible conclusion. No. There are not too many corners in nature, but that might explain something about what they like to do to hide. They're going to look for somewhere that is sort of protected and in a corner or between things. That might be a preference.
So let's think about that. If we look at the control.
Molly says we made a mistake. We have the rocks and the seaweed reversed. You're right. You're absolutely right. We had 6 in the seaweed and only 3 in the rocks.
Oh, thanks, Molly.
Good catch.
No problem. We can fix that.
Done. Okay.
Hey.
Now we got some accurate information. All right, so why don't we do a little crab math? I like Iris. We're just going to count how many are doing each behavior. So center was easy, 0 down the whole experiment. Control, how many crabs total spent at least a minute in the control, in the corner that was empty? 1 + 1 + 1, that one's pretty easy.
All
That
right.
makes 3.
Tell me, can you see the red if I say 0
Oh, yes.
here?
Yeah, that's nice and dark.
3 here?
Good. Yeah, we were having trouble with the green, but the red is nice and easy to see. Okay, so let's see. We got a little bit more math to do here. So let's see, let's add up the seaweed. 5 and 4 is 9, plus another 5 is 14, plus another 5 is 17, plus another 4 is 21, plus another 6 is 27. Did I do that right? Check my math at home, people.
Okay, so we're
27.
saying 27 for the seaweed.
Okay, how about sand? That one's a little easier. Fewer, definitely. Okay, so 1 and 1 and 1 is 3, plus 3 is 6, plus 2 is 8.
Okay.
So 8 crabs.
8 for the sand.
Excellent. And rocks, lots of 4s there. Huh?
Yeah.
All right, I'm going to do some multiplication. I'm going to do 4
4
times
times
4
4
is
That's what I was
16.
thinking.
Right? 16 plus 3 is 19. 19 plus 3, 22.
All right.
Okay, so based on our results, which habitat did the crabs prefer today?
Seaweed. Check
Seaweed,
that out.
yeah.
27
Not by
crabs.
a ton. You know, we had some crabs spending a lot of time in the rocks. So maybe we could redesign our experiment to test this further. So a couple observations that I saw pop up while we were doing our experiment. We saw some people notice that the larger crabs were making different choices. So the smaller crabs have an easier time fitting in between the rocks. And that's important when we talk about why we find so many shore crabs around here, is they can fit in between rocks really well. The ones that couldn't fit in between the rocks very well spent more time in the algae. Right, so maybe we had some larger crabs. So again, we could change our experiment to see if females with eggs did something different. We could see if crabs of different sizes did something different. But based on just our observations today, they preferred the seaweed. But that's not usually where we find them in the rocky intertidal. That we usually find, or in the intertidals, and we find them in between the rocks. That's where we go to look for them. One of the reasons they're so successful is they can survive in a lot of different habitats.
That's right. And one of the things I will notice or mention about our intertidal out here is a lot of the rocks are covered in seaweed. So we could even consider combinations of these habitats that we were testing today. So when I kind of look at these numbers, it seems like some kind of cover is better than no cover at all, right?
Right.
So whether it's the seaweed or the rocks, they seem to prefer those kinds of habitats because I think they feel more protected there.
Now, what kinds of predators do you think they have out here?
Well, I see lots of birds along the shoreline, so birds would totally want to eat those crabs. I think that's one that they would need to consider. And then depending on what the tide is, right? So when the tide is higher, that might allow other predators like fish to come in that might want to feed on those crabs as well. So there's a lot of different predators depending on what the tide is doing.
Yeah, so they can hide from their predators with some cover. They also, the birds around here will eat them, but they don't have any natural predators here. This is where I'm kind of going with this. They are pretty good bottom cleaners. I'll tell you what, they're opportunistic scavengers, so they'll just eat anything that's down there. Omnivores too, so they'll eat some algae as well. So they don't have any natural predators because they're actually an invasive species.
Dun, dun, dun.
So that means they didn't originally start here. If you watched some of our previous Facebook Lives, they come from Asia. They're the Asian shore crabs or the Japanese shore crabs. And scientists believe that they came here in ballast water, the first part of their life cycle. After those tiny eggs hatched their plankton, and they got carried here in ballast water aboard boats. So they may have accidentally been introduced, but now we found that they're really good at surviving in lots of different types of habitats.
Right.
They don't have any predators. They reproduce really fast compared to other crabs, and they're even better at hiding between rocks than the other species of crabs that are around here. So that means they might outcompete.
Yeah, they got a lot of things going for them here.
Yeah, they sure do.
Helps them to be successful even though they're not native to this area.
Okay. So is there anything you want to add? I think that just about the right amount of time for our program today. So if you have any more questions about our experimental design or about Asian shore crabs or Long Island Sound, post them in the comments. We'd love to answer them for you. Join us on Thursday. We're really excited about Thursday. The entire education teams, Callie and I, and Kyle and Marissa are going to be aboard the Enviro Lab doing our first Facebook Live trawl. So we're going to set our otter trawl and pull in some animals off of Long Island Sound. And tune in. I'm just so excited to see what's living down there.
Wait to see what's there.
It's our favorite thing to do at Project O.
The water's getting warm, so that's a good sign.
All right, I hope you guys can think of some experiments. Maybe you can try an experiment like this with an organism in your backyard. If you've got some beetles or something like that you'd like to try, replicate our experiment. Do some science out in your backyard, and we'll see you on Thursday.
All right, thank you.
Bye.
Bye.